Hello, I am Dr. Leah Leach, the headmistress of the Uhura Training Academy and the founder of Gal's Guide. This is the third week of the online version of Uhura's Training Academy. Today, we are going to be looking at the history of navigation, sailing, space, science. It's awesome. We're going to be cross-comparing old sailing techniques and spaceflight, learning how these tools and how the technology involved is very similar and why it's so similar. So not sure how many of you have ever been on a boat before, how many sailors we have, not sure how many astronauts we have. There's not too many people that have ever been to space. Safe to kind of assume there's very few of astronauts, but you never know. So if it has been a bit since you've been on a sailing vessel or space, I have two videos to catch you up. I'm going to show you this first one. It is a TED's Ed instructional video, and it's called How Does Math Guide Our Ships at Sea? And it's really good to show you visual because this is an animated video and it's just about 4 minutes and 18 seconds. So I'm going to share my screen. There were two main components that could pull a ship off course. They were wind and currents. So early sailors would use that dead reckoning, and the video isn't the clearest on the dead reckoning, so I thought I would go kind of back over it a little bit. Dead reckoning, which is totally something like a pirate would say over and over again, is keeping track of the direction, the time, and the distance from where you left, knowing where you've come from to know where you are going. So if you are going north or south, east or west, how long have you been at sea? Those calculations will give you the miles away from home that you are. But then you also have to question, what if the note taker fell asleep? Or if in my head, because I'm still imagining pirates eaten by a kraken, because I feel like that's the ongoing daily problem of pirates. Then what tool could they use to figure out where they were? And that's where that sextant comes in. That's the thing that's part telescope. It looks like a triangle with a telescope on one side, a ruler on another, a protractor on it that was in the video. It measures the altitude and the angle between two objects. Usually the sun and the horizon, sometimes also the moon and the horizon to get the angle of those. So, all right, so for navigation, we have so far that we have learned that a sailor needs to be brave enough to go out into the big open ocean without always having visible land in front of them. That's a very brave thing to go do. I'm gonna head out that way and see what I can find. Dead reckoning is a tool to keep track of where they have been. And the sextant is the measurement between the sun and the horizon, or the moon and the horizon, to give you an angle trajectory. And the other thing that the video said that we need to be able to navigate, along with all those other things, is math. Right, so bravery, a method, a tool, and math. So those are the things that we need for navigation of the sea. So my future space travelers, do we need the same thing? So bravery, yes, absolutely. Strapping your butt to a rocket involves a lot of bravery. Math, a crap ton of math, absolutely. And a method or tool to measure. Well, when it comes to the vastness of space, we can't necessarily use the sun and the horizon line always, right? So when it comes to vastness of space and landing points, the trick is using light, because planets are always in motion. They are always moving around. They're not constant. So when it comes to now looking at a contrast and compare of sea to space, we're going to look at light. We're going to look at light in seconds, we're going to look at light years, and we're going to look at light centuries. Again, above my pay grade. So we're going to look and learn about light. This video is 5 minutes long, another TEDx glorious tutorial to measure distances and calculate our trajectory in navigation. We need to measure in terms of light when it comes to space travel. I thought it was absolutely fascinating how the sun, which is relatively close to us, is still an 8-minute delay. We are seeing the sun 8 minutes ago from when it's existing, so it's 8 minutes late. And then stars like the Big Dipper, it said, were 80-year delay. And those smudgy galaxies, the ones we can kind of barely see, are millions of years ago that we can now see them. So I was trying to think of something that is similar to this on Earth to kind of, wrap our mind around, okay, well, that's cool. What does that mean in practical terms? So here on Earth, we actually have a time shift that we do account for when we travel long distances. Like, let's say if we travel from Los Angeles to London, we have to account for time zones, right? Okay, so why do we have to adjust to this time change, okay? Why isn't it when you just get on a plane from here to Sweden, it's just the 13 hours that it takes to get there? Why do you have to calculate for those time zones, right? And it is because, if you've never really thought about it before, the sun doesn't rise and set the same time everywhere on Earth. So as the sun sets in Indiana here tonight, it's actually coming up over Singapore, right? So it's not the same time everywhere. And we have this really human characteristic where the day starts when the sun comes up and the day ends when the sun comes down. And it's why we also struggle with daylight savings time, even when we just change our clock 1 hour, either way. But with changing clocks, it's not like that everywhere. In Lapland, Sweden, during the summer months of May through July, so now in Lapland, Sweden, the sun never sets. In Alaska, it's the same thing. It's that latitude line of where the sun hits while it's on its rotation with the Earth, and it's called the midnight sun, which is a term I've always loved, and I've actually always wanted to call a book Midnight Sun, just because I just love that title. But then I hear the Twilight books are gonna, anyway, it's a thing. So we have variables, is where I'm going. We have time zones, we have time changes, we have countries that have a midnight sun during different parts of the year. So that can make tracking by light very hard in space, just looking at the Earth as an example of perspective, okay? So the question is, would something like that sextant that measures the angle of the horizon and a solid object, would that work in space, right? Could you have two objects to view and measure your altitude in space as if you were on a sailing ship? And the answer is actually yes. So this is a very quick video. This is just like a minute and a half that actually looks at using that navigation of space using the sextant, and it's very fascinating. But the same device, and that's all of the video, so I won't have any more torturous videos for you. The same device that sailors used at sea not only have been used in space, but they are testing it on the space station. Something that we have been using in sea in space. And to learn a little bit more, it might be a wonderful emergency tool in space flight, because who knows if we can ever get our flying cars or our trip to Mars. I think that this would be a really good tool actually to have. So the sextants have a small telescope eyepiece to take an angle measurement between a pair of stars from land or sea. and it doesn't need a computer. So computers are awesome, but what happens when you have a huge computer failure? You saw on the Gemini and Apollo missions, they were conducting experiments to see if that device would work. Now, not so ironically, if you know your history, the Apollo 13 mission did have a computer fail. It was because of a small explosion that happened outside the aircraft. Now, Jim Lovell, the same guy who was just in that video, who you didn't hear because apparently there was no audio, he was showing how the device works. Now, what is really ironic is that when they tried to use that device to be able to get themselves back because the computer was not working on Apollo 13, there was too much debris that was around the spacecraft from the explosion, and they couldn't tell the stars from the debris. So it actually wouldn't work in that particular case. However, what did work is a fixed point in space and being able to do the math. I'm going to be able to actually go more into detail on that in our hidden figures of how Katherine Johnson made sure that Jim Lovell and the other astronauts knew how to do the math in case the computer broke down. It's a fascinating story. But using that fixed points in space is basically kind of heading towards the land mass, if you will. If you were on a sailing vessel and you see an island or you see land ho, heading towards that direction. So the team at NASA and to a certain extent at SpaceX as well are testing the Sextant again in space because they want to generate some new ideas and get a cleaned site on fixed points that they can or can't use in an emergency situation. With the right techniques, the crew can use the tool to navigate their way home or between different angles between moon and planet and stars, and communications if the computer is compromised. And you saw in that wonderful video, the program director said, quote, "No need to reinvent the wheel when it comes to celestial navigation." He continues in another interview that I saw. He said, quote, "We want a robust mechanical backup with as few parts, as little as needed power as possible to get you back home safely. Now that we plan on going farther into space than ever before, the crew needs the capability to navigate autonomously in the event of a lost communication with the ground." Basically, if you're going farther away, there's less chance of your connection working. I mean, think about it, the farther away you get from your Wi-Fi, the less, your Zoom call really works all that well. Same kind of principle. I might be stretching it a little bit. But this is one of the many reasons that I love history so much, and I love that NASA looks at existing technology, some would call old technology, to improve upon it, to use that hundreds of years of foundational knowledge and put it to a new use, put it to a new upgrade, a new application. I think it's fascinating. So let's look at a few more navigational tools that we can use to navigate sea and space, mostly sea in this particular case. The first one that we're going to look at is birds. Now, I loved talking about pigeons when we were talking about communications. This one's pretty cool too. Now, birds are probably not a navigational tool that you would necessarily think of right away, but the Vikings used ravens to find land when they were exploring. Apparently sailing around and just looking for new land to conquer, they used birds that they had on the ship. They would let the bird go fly out, and they would fly up to 5,000 feet up, and they would look around. If they saw land, they would fly in that direction. If they didn't see any land, they would circle around the boat and eventually come right back to the boat. This didn't work with just any bird, of course. It'd have to be a non-migratory bird, one that was not accustomed to flying over water. In other words, it had to kind of hate water. Because if it hated water, it would come back to the boat. Or it would go towards the land that it would see ahead. It also had to be big enough to fly at a great height, and it needed to have excellent eyesight as well to be able to see those. So there is a story that possibly Iceland was discovered using birds, right? Another way birds are used in navigation is not by having them as a possible unwilling passenger, but just observing birds like Mona is doing right now in the chat. If you are sailing at sea and there is a large group of birds that are eating on fish, there is a strong chance of land nearby. Following the birds as they return the food to their nest is an excellent way of navigating yourself back to dry land. The next one we're going to look at is stars. Okay, so stars in a sailing navigation context. So the stars on a map of the sky is a wonderful navigation tool. Like many maps, you just need to know how to read it. One of the first steps is to understand how the Earth, the moon, the sun, and the stars, how they move around each other. Learning astronomy. Taking an astronomy class or reading a book or watching TEDx videos is a wonderful thing to learn about. Learning the phases of the moons and what constellations are easiest to find during different times of the year are just fascinating. One easy experiment that you can do throughout the year is to track the Big Dipper's movement across the sky, especially during winter. Winter is when you can see Big Dipper dramatically shift. There is one star that you can see year-round, and it's pretty bright. I'm sure you guys know this wonderful star. The North Star, or Polaris, is a constant in our sky. Now, the star is pretty close to the same spot all the time. It does wobble a little bit, but it stays on the north axis of the Earth. And by knowing this star, you know what direction north is at night. Now, also, if you know the second star to the right and you take it straight on till morning, you can find Neverland. Sorry, I can't resist. I really can't. And then as a Star Trek reference, you can probably also find Captain Kirk in the 6th movie too. Anyway, so the next one is the sun. Now, you're not supposed to stare directly at the sun, but what about when it's daytime and Polaris, the North Star, is not out there? It is much harder to see the stars when the sun is shining brightly. So you can use it for navigation. One of my favorite lines in Avengers is when the navigation system is broken on the helicopter, the helicopter, or the helicarrier. Sorry, helicarrier. I'm trying to combine two words and I'm just throwing two words together. But Nick Fury says, "Is the sun up? Then put it on the left." Sorry, I love how simple it is. Because the sun rises in the east and a morning sun would need to be on your left so you could head south. So the sun is also a navigational tool as well. If you have made a sundial at some point in your life, you know exactly what I mean. The simplest way to make a sundial is to use a stick and a flat surface. As the sun rises, it moves throughout the day and it leaves a shadow on the stick that rotates like a clock face. So another interesting observation about navigating on land is the saying moss grows on the north side of trees, right? If you're here in the northern hemisphere, yes, it does. Okay. It also grows on the north side of houses as well, because the north is usually more in shade. It doesn't get as much direct sun. In other words, moss likes to grow where it's a little bit shady and a little bit colder. There are exceptions to this, but it's an interesting observation of finding which way is north by looking at where moss is growing, either on trees or even on houses and buildings. Another one is a compass. I do have a compass It's one of Gal's Guide's, it's our logo is a compass, so I always have a compass around here. A compass is a fantastic tool used to help navigators know which way north is. It uses the Earth like a giant magnet, and the north end of the compass is meant to line up with the magnetic North Pole. Explorers have used round objects that's basically a magnetic needle that will pivot around and find true north. If you've ever done one of those experiences where you take basically like a sewing needle and you rub on it to make it magnetized, and then you float in water and you'll find that it points north. I'm trying to see if I can find it on my phone. We also have compasses on our phone now. I don't know if you know this. Utilities, compass, there it is. Let's see. There are compasses on our phones. It comes standard equipment, and it's quite detailed. It's fascinating. These are fun to just like go out and explore with. So yes, I always love compasses. It's also the reason why it's Gal's Guide logo, because compasses don't tell you which direction to go. They tell you which way north is, and then you decide your direction. That's why I like them. They give you a direction and then you decide where to go. So in the early sailing days, a compass was used also to identify the direction of the wind because there was a strong chance that that would mess up your navigation. It would push against you. A compass can also be used to, you can also make a compass using a cork, the magnetic needle, and even a puddle of water will even do it as a water source. There are YouTube videos on how to make your own compass. They're quite fun. Me and my daughters have made many of them. The next one for navigation is maps, glorious maps. I will try to not sing any Dora the Explorer songs. Around the year of 1200, mariners thought that maps would be helpful, and they began keeping detailed records of their voyages. So the Portalin charts were the first nautical charts, and they were created on sheepskin and goatskin. They were tried to keep a secret from other mariners, but they were very well highly decorated, and they had many images of buildings and flags and important things that they found on them. Now, the size of the land on early maps was a reflection of their importance, not their actual size. So if a trade route was really, really important, that particular area on the map would be ginormous compared to everything else. The maps also in the early days did not have latitude or longitudinal lines, but they did have a compass. They were also, of course, not very accurate because the ability to measure distances at sea had not yet been developed. That would come later down the line. But that is early maps. The next one is radar, jumping ahead. So radar. Radar actually wasn't in use until 1935. We haven't been using radar for that long. Which actually was surprising to me that it's been a bit. The ability to locate objects beyond the visible range was just amazing. It used radio waves to determine the existence and the distance of an object. And it was used in marine navigation, but then it's also used in airplane traffic. It's also used in weather patterns, and it's used in space travel. Radar is also used in space travel as well. Then our next one is GPS. I think we're quite familiar with GPS for navigation. Some of us might be like, screw all these other things. I just need my GIPs. And I can find anything. So most of our navigation on Earth now uses the GPS satellites. So GPS actually stands for, if you want this fun little trivia fact, if you didn't know, Global Positioning System. It started in 1973. It was mostly used for the military. Each time that we want to know our exact location on our glorious phones of GPS, we ping 4 satellites, and it sends the signals back triangulates those, converges those, and tells us our position only a few feet plus or minus. So 4 satellites are to tell you how to get to your target. And I was thinking the target store, not necessarily like, you know, the target destination. But anyway, but what if you are the military and you don't want to give your location away? But also, what if the satellite is jammed or one of the 4 is down to be able to find your location? So then, just like how NASA looked at navigation tools of the sun, the stars, and compasses and maps, you now know that you have a variety of different ways to find your way home. So yes. So I will open it up for questions and discussion about the history of navigation and all of that fun stuff. Thank you. You guys can unmute yourself.